Bonsuelo Mathletes, the beginning of a new chapter, chapter 2. What are we going to deal with in this chapter? Graphs. Okay, what did I say we pretty much do? And I'm going to scribble something on this page. You don't need to write it down. What did I say we pretty much do in math? First, there are things that are not equations. Don't write this down, just listen, because it doesn't belong where I'm writing it. And what do you do with things? For the most part, you simplify those. Okay. Second, there are things that are equations. And what do you do with those? Well, you either solve an equation, you solve a word problem, which is just a type of equation, only you have to figure out what the equation is instead of it being given to you. And we've done all that. We've simplified, we've solved equations, we've solved word problems. Okay, so what's the only thing left to do with an equation? Graph. Okay, so that's what we're going to be doing in this chapter. Okay, but before we get to any of that, there's something I want to mention that you should always be aware of, and that is, okay, it is not enough to know how to do something. You have to know when to do it. In other words, it's not enough to know how to simplify something. You have to know when to simplify. You simplify things that are not equations. It's not enough to know how to solve something. If you try and solve something that's not an equation, you're wrong because you're doing it when you shouldn't be doing it. Okay, so you should know what it means to solve and how to solve, but you have to know when to do it, and it's an equation. Okay, well, what does that have to do with a graph? Well, you have to know how to graph equations, but there are different types of equations. And you should know what the graph of something's going to look like before you ever graph it. You should be able to look at an equation and say, okay, that thing's going to graph, as whatever shape it's going to be. Now, if both solving problems and graphing problems are equations, okay, well, how do they differ? Okay, this is basically it. I mean, this isn't like 100% perfect, but it's something like this. If you have this, 3 equals 2x plus 7, most likely you're going to solve that for x. If you have y equals 2x plus 7, most likely you're going to graph that. Okay, and again, you don't need to write any of this down. I'll say it plenty of times. Just kind of listen right now. I'm going to erase this bit that I've written down. I'm going to erase it in a few minutes. But generally, you're going to graph something that's got two variables in it. Now, could I take the equation y equals 2x plus 7 and solve it for x? Sure, I could. So yeah, it does depend on what the instructions are. I could ask you to do other things like find the x-intercept, find the y-intercept, fine. Okay, but generally, that's kind of what we're going to be doing this year. We're going to simplify things, we're going to solve things, we're going to apply it on a word problem, and then we're going to graph it. Okay, so let's just start talking about graphs. Again, you don't need to write, matter of fact, you probably shouldn't have any of that written down. Doesn't really belong here. Just kind of wanted to give a brief introduction of where we're headed. Okay. Before you do anything, you should always know what type of equation you're dealing with. Yes, you need to know that you're dealing with an equation, but you need to know what type of equation you're dealing with, especially when you're graphing. So here, there's something called a polynomial equation. And what's a polynomial equation? We'll get more into this later in the year, but basically, it's got a whole number exponent on the variable. Okay, well, what's a whole number? It's no fractions, no decimals, no negatives. So something like 0, 1, 2, 3, 4, et cetera, et cetera. So again, you don't need to write this down, okay? But if you have something like y equals 5x to the third plus 7, that's a polynomial. A little more specifically, it's a cubic polynomial. But that's an example of a polynomial. Also, just so you should know, a polynomial has no math operations around the variable. okay? Now, it could have plus, minus, multiplication, division, or parentheses, but what do I mean by a math operation? It's not going to be this. And again, you don't need to write this stuff down yet. You just need to listen and kind of follow along with the notes. What if you have this? The absolute value of 5x cubed plus 7. Okay? That's not a polynomial because it's got an absolute value around the variable. What if you had this? Y equals the absolute value of 5 times x cubed plus 7. That would be a polynomial because notice there is no math operation around the variable. Remember, I've always told you, if you want to know what type of equation you got, you always look at the variable. Okay, what if you have this? Y equals the square root of 5 times x plus 8. That is a polynomial because the variable exponent's 1 and there's no mathematical symbol around the x, around the variable. But what if you have this? The square root of 5x, that whole thing, plus 8. Then that would not be a polynomial because it's got a radical symbol over the x. Okay. So, and again, I'll say plenty of this. You don't need to write these examples down. I'll say this plenty of times. Okay, main thing I want you to do right now is listen. And again, listen and ask questions. So if you've got a question on this idea, ask me. So basically, you should know what a polynomial is. All right. Okay, there's something called the degree of a polynomial. It's not that big of a deal, but it's just the largest exponent on the variable. So for instance, the largest exponent on the first one, this by the way, these you would not graph. Okay, because they've got 0 here. If there was a y here on these, you'd be graphing them. But this all applies to whether you're graphing or solving. It doesn't matter. So, okay. So the second one would be a cubic, a polynomial of degree 3. And the third one there would be a polynomial would not be a polynomial because even though the x is to the 5th power on the first term there, on the 7x to the half power, that's not a whole number exponent on the variable, so that's not a polynomial. What is it? We'll talk about another day. Okay? All right. Now, what are the types of equations that we've looked at so far this year? We haven't graphed anything, but we've solved them. The first is called a linear equation. It has a variable exponent of 1 and no other math symbols around the variable. So, for instance, I'm going to write something down here again. Don't write it. If this had a square root over it, that would not be a linear equation. Okay, if it had an absolute value around it, that would not be a linear equation. That would be an absolute value equation. If it had an absolute value just around the 2, or if it had a radical just over the 2, then it would still be a linear equation. Okay? Now, again, linear does not mean makes a line. Okay? What would the instructions for this equation be? It would be solve. There's no second variable here to graph. Okay? If, for instance, instead of 13, you had a y here, that would be a linear equation. It'd still be a linear equation, but it'd be a linear equation you would graph, and it would end up to be a line. Okay? But linear does not mean line. Okay? Linear means the variable has an exponent of 1. And there's no other math symbols around it. So, for instance, the second one here is an absolute value equation, and we've dealt with those absolute value equations. Okay, there's a variable inside the absolute value. Okay, again, I want to emphasize, just having an absolute value in a variable doesn't make it an absolute value equation. If this was the problem, this would be a linear equation. There would only be one answer to it. okay? So again, for the most part, I'm just trying to get across what makes a certain type of equation. Okay, so again, there, notice 2x plus 7 equals absolute values. 13 is not an absolute value equation. Why? Because the variable's not in an absolute value. Okay, well, we've only solved equations. We've solved linear equations. We've solved absolute value equations. Okay, in chapter 2, we will graph equations. So an example of a linear equation is y equals 2x plus 7. Quadratic is a polynomial of degree 2. You could write this down if you want to, like y equals 5x squared plus 3. A cubic equation is a polynomial of degree 3, so that's like y equals 5x cubed plus 13. Okay, and there's another one here that I forgot to mention, and that's an absolute value equation. And that's got a variable and an exponent. For example, y equals, let's say 3 times the absolute value of x plus 4. Okay? And you might want to write those 3 examples down, so if you want to go back and look at it. But they're basically polynomial equations. The first 3, linear polynomial of degree 1, quadratic polynomial of degree 2, cubic polynomial of degree 3, meaning it's x to the first, x to the second, or x to the third. And then we're also going to look at absolute value equations. Okay? So, I just want to get across here again. It's not enough to know how to do something. You have to know when to do it. So, when are we going to graph a line? Not everything graphs a line. You graph a line when you have a linear equation. This one at the bottom here, the absolute value equation, it doesn't graph as a line because it's not a linear equation. All right? So that's all I want to say for right now. It's kind of brief, but make sure you know when to do something. Okay? Not just how to do it, but when to do it. Have a good day, everybody.